So, hi everyone, I'm Tom Giles. I work for the University of Nottingham in the Digital Research Service alongside Bill Quinlan. And my background is bioinformatics, but actually what I find myself doing more than anything at the moment is stuff to do with federated discovery, big analytics in healthcare, and federated analytics amongst trusted research environments, and some of the more physical aspects of that and how actually to get things working. So today I'm going to talk to you about CaRROT, which is one of the toolkits we've created specifically for transferring data into OMOP, which is a common data format. I will talk to you in a bit more detail. And I'm also going to talk about some of the other bits and pieces that we are doing. So I've kept this relatively simple, this section. I've actually stripped it down a little bit. So what is fair data? Why fair? So for those of you, I reckon a large portion of the room will know, fair data is findable, interoperable, accessible, and reusable. And the whole idea is that any data that we're generating should be interoperable enough that it can be reused in other studies. So why does fair matter? There's lots of health data. There's more health data being created than in any other of the major industries at the moment. And the rate at which we're generating health data is just constantly increasing. So we need to be innovating in order to ensure that we are able to reuse this data in the future. So our journey into the space was largely accelerated by a project recently that we've just completed called CoConnect, which was around the federated discovery of healthcare. CoConnect was a £4 million research project that ran over the grand total of 56 months. And the aim of CoConnect was to standardize antibody data collection, how it's stored, and make it discoverable. So as part of that, there was the standardizing how people were collecting antibody data. Part of it was configuring infrastructure for secure data analysis. And then the primary outcome of that was to try and help researchers answer key questions about immunity and COVID-19. So our main focus in this project was providing these tools and infrastructure components to make healthcare data discoverable for reuse. And CaRROT, which is the major block of this talk, is one of those tools that we generated. So CoConnect focused on connecting various federated resources up to the HDR UK CoRROT discovery platform. The way we did this is we installed a local connector within each of the partners we worked with's data infrastructure, and these connected securely to a centralized portal on HDR gateway called the HDR UK CoRROT discovery tool. So users can register to the HDR gateway. They can go to this graphical user interface. They can build up complex queries. So you could build up this example here has all the males with asthma. You could then strip that down. So I only want males between 24 and 35 with asthma who also have a history of smoking. And what this will do is it will go away and present a query on a queue, which is then pulled down into those data partners' local infrastructures. That is processed internally on those nodes. An aggregate count is generated, which is subject to obfuscation, returned back to the central portal, and you get back these kinds of statistics of how many people match that query. This is really useful because it gives people an in of how they can find resources that might have data that they want. So in this instance, looking at it, I mean, Generation Scotland seems to have the most asthma patients that are male. So your next step, if you're designing a research study, might be to approach Generation Scotland and start the conversation as to whether they have the data available. One of the big things actually as well is that this actually reduces the load on data partners quite a lot, because a lot of the benign queries that usually would go to a data partner and then would need a research data engineer to dig into the data to answer can be answered straight away, which means that they're not doing a lot of that kind of work. And I had some really interesting conversations with some of the SDE networks recently about this, because I think a lot of the SDE data requests tend to be along the lines of, do you have these samples? So this system actually already supports federated analytics as well, which is quite interesting for some people. So the current modules that work are FEWAS, which allows you to search across an OMOP data space based on the differences between two variables, GWAS for genetic data, and a standard burden test. These are not implemented in the live system as of yet, but there is conversations at the moment going on within HDR to move across to the newer release of the software and potentially implement some of these federated analytic components. So the current implementation is based on a collaborative relationship that's been going on for a long time now between ourselves, HDR UK, and a company called BC Platforms. And they provide the overall infrastructure for the CoConnect project, and they provide the HDR cohort discovery tool. There are lots of partners in CoConnect. We partnered with people like ONS, SAIL, UKHSA, PHS, and throughout the CoConnect project, we've been largely successful in getting the infrastructure installed and actively running in a reasonably large proportion of these partners. So moving on, what is CaRROT and why do we need CaRROT? So CaRROT is a convenient and reusable rapid OMOP transformer. So as you all know, the problem with healthcare data is that data resides in lots and lots of different formats. Some of it's structured, some of it's not structured. So what you end up with is a load of oranges and raspberries. What you really want is a load of apples. Fortunately, there are standards that already exist out there that allow you to harmonize data from dispersed healthcare records. These are known as common data formats. Two perfect examples here are OMOP, which is provided by OHDSI, and HR7 So HR7 is more of an infrastructure layer than necessarily a common data format, whereas OMOP is very much just a common data language. There's also a lot of collaboration going on between HR7 and OHDSI, and they're looking at how they can interoperate their two languages at the moment. So the big problem here is not that the standards don't exist or common data models. It's that often data partners don't actually have the expertise to convert their various data sets into these common data formats. So with CoConnect, what we needed to do was we needed to work out a way that we could get people's data into OMOP without ever actually having to touch their data. Because we did not have time in the CoConnect project to do data processing agreements for every single data partner. We worked with 35 data partners. If we tried to get an arrangement where we had members of staff seconded into every single organization, it would have just taken forever. So what did exist out there, though, at this point was tools to profile data sets, to get an index of a data set. And if you look here, there is a lovely little diagram, and you can see a database being pulled into a tool here called White Rabbit, which is provided by OHDSI. And what it gives you is, for a database, an index of that data that gives you the tables, the field IDs, what kind of field they are, what percentage is empty, what percentage is unique, so on and so forth. So you can get quite a lot of high-level information about data set. And HDR UK are actually using these same profiles for the Platinum standard on their cohort portal, the high-level cohort portal. So if you want to get a Platinum cohort on the HDR cohort browser, what you need to do is submit one of these White Rabbit scan reports. So this has worked out really quite nicely for us. So these White Rabbit scan reports contain a lot of information. They are intrinsically non-disclosive. You can actually, in White Rabbit, configure disclosure controls to obfuscate data so that you can't drill down to individuals, essentially, in these outputs. So when we started the CoConnect project, no tool actually existed to map the data from your apples, your raspberries across, sorry, your oranges and your raspberries across to your apples. So we developed CaRROT. This is a big, complicated diagram, and I'm going to take a minute or two just to go through it. So what we did is we went to a data partner on the bottom left and asked them to extract a non-identifiable version of the data that's pseudonymized. We then ask them to run a White Rabbit scan report on them. That White Rabbit scan report is non-disclosive, so they were able to pass that out of their local infrastructure. What they did is they then gave us that White Rabbit scan report. We developed a tool called CaRROT, which is a GUI interface that allows users to upload these White Rabbit scan reports. So users could be our own data mapping team or other people, but actually also use this resource. That allows them then to map their data to OMOP. This generates a series of JSON LD rules, which we can pass back to that data partner. And then we have a second tool called CaRROT CDM, which actually does a transformation on that data. What we also asked the data partners to do was put that pseudonymized data into a DMZ, run this mapping so that the OMOP standardized data was then in a place where we could connect it outbound to the HDR Innovation Gateway. So this has happened in lots and lots of places now, and it's a fairly standardized process for us. And I want to talk to you a little bit more about the details. So CaRROT is a GUI-driven application. It allows users, as I said, our own mapping team, but we also have a load of other users that can use it now, to upload and view White Rabbit scan reports. You can see on the right-hand side here, I've got an example of all the tables from a scan report. Users can then sort of map existing data structure to the OMOP common data model. And you can see here how I've got some basic term mappings. So if observations, COVID antibody test source field result is 1, then I map it to this observation ID in OMOP. CaRROT is quite clever. It stores every single mapping that has ever taken place and then uses those to try and re-infer the mappings for a new data set, if you had a new data set. What this means is as we put more and more data into it, it gets a little bit smarter and reuses those rules more effectively. Obviously, you have to check them, because if you've reused a rule, there's a possibility that it's wrong. But what this does mean is when there are small changes to a data model or a data structure and we upload a new data set, it almost always captures the data and remaps all of it automatically. Users can actually visualize the flow of the mapping rules that they've created. So here we've got a load of mappings from this baseline data file that go to a load of terms in OMOP. And you can see which tables they're hitting. So CaRROT is currently being used by lots and lots of people. This is probably slightly out of date, but we have something like 50 or 60 scan reports up. We've created something like 300,000 mapping rules. You can see that quite a lot of data partners have been involved in this, and quite a lot of mapping rules have been created for different data sets. Public Health England, for example, we've created a lot of mappings for, but that's because the data sets we've been working with Public Health England have been huge. We're also using this across other teams. So there's Demystify, CoConnect, Alleviate. Twins are using this directly, and BBMRI are currently in talks about using it. So where are we going with this, and what are we looking to do, and how are we looking to grow it? One of the big things that's coming up at the moment across Europe and the UK is how do you make sure that the provenance of these tools is captured? So when you're converting data from one format to another format, how are we capturing that something has happened to the data and the sort of quality of that conversion? So one thing we're trying to do at the moment is collaborate with Elixir to see if we can use RO crates, which is a community effort to establish a fair, lightweight approach to packaging data alongside of contextual information. It's a JSON LD format again, to capture alongside the actual transformation itself some of the meta information about that transformation as a workflow. So our hope is by capturing this additional information, we'll be able to make it easier for research to access the information about, the provenance, history, and quality of the OMOP converted data sets that we are generating. So we're also then looking to export the metadata to the HDR gateway in a more automated fashion, and actually having the RO crates component there, wrapping up our pipeline, capturing all the meta information around that data set at an early stage would make it very easy for us to do this kind of automation. I want to sideline slightly and talk to you just briefly about the other tool that we're developing. And just to put it into context, there's a lot of synergy between the two. So the other tool we're developing at the moment is called Hutch. It's a heterogeneous data connector for healthcare. So Hutch is open source and will always be open source. And the idea is that a lot of partners at the moment that we've worked with are not sure about using BC platforms as a commercial partner. So we wanted to be able to offer an open solution that wasn't BC platforms. But actually what's happened as a result of all of this is Hutch has grown a lot more than we initially planned. So the idea of Hutch is, rather than BC platforms, which is very data focused, it's really a slightly different product than how we've been using it, is that we wanted Hutch to be primarily for this data discovery effort and to be more focused around data controller use. So Hutch is a GUI-driven application that sits within a secure data environment, and it allows data controllers to configure connections between databases or data sources and discovery and analytic portals or platforms. So one of the big problems we have at the moment with federation, certainly within trusted research environments and secure data environments, is that every time a new technology comes along, a new federated analytic tool, a new federated discovery tool, there's essentially just a bespoke solution for that federated analytics tool, which means that TREs then end up implementing a load of different secure profiles. So this becomes really, really difficult, and it's really, really difficult to manage, both from a TRE perspective and also from the perspective of the users as well. So what we need to do is find a better way of doing this, and a way that doesn't involve 150 arrows. And we need to do it in a way that's conformative with the HDR UK and 5 safes model, and can also be validated against PPI and governance. So what we're trying to do here is use RO crates again. So we're trying to use RO crates as a federated transfer layer for TREs, and we're testing this with free federated analytics and federated discovery tools. So the two main ones are Bitfund and DataShield. But as part of this, we also want to be replacing that component from BC platforms that sits locally within a secure environment and allows people to do federated discovery queries. So what we're hoping is this is going to be much more platform independent, much more scalable, and much more easy to validate by the TREs and secure data environments. So Hutch is built on a 5 safes RO crate, which doesn't quite exist yet, but it's coming very, very soon. We're developing in collaboration with Elixir. So the whole idea is to make this as interoperable as possible, and try and make machine actionable the structure, history, authorship, and provenance of queries, federated analytics, federated discovery. It doesn't matter. It's meant to be agnostic. So within Hutch, SDE controllers can view and configure activity sources, users, workflows, projects. And what we have within Hutch now is a submission zone that sits outside of a TRE, a polling zone, which is essentially a demilitarized zone, which once something is pulled into a TRE, then allows us to validate that query coming in and check that the person's right, that the project's right, and that they're asking to run something sensible on a data set. That then gets pulled deeper into a trusted research environment, into a controlled zone where the data actually resides. And then we are using a workflow handler called Workflow Execution Service in order to execute workflows. So the Workflow Execution Service is part of the OSC Live project, also co-funded by Elixir. And as part of this, for transparency, we're trying to make all the workflows we're generating publicly available on Workflow Hub. The Common Workflow Language Execution Service the execution service will work with a lot of different languages, including Common Workflow Language, Galaxy, Nextflow, SnakeMake, and there's a number of others as well. So the currently supported protocols that we have within Hutch are kind of the HDR UK CaRROT Discovery Tool and BBMRI Finder, which are both built on the same technology, RQuest, part of that BC Platforms piece. We are then moving towards support for Bitfront Data Shield. And what we're hoping is also that the same technology stack should be able to support things like Global Alliance for Global Health's Beacons API and metadata catalogs. This then gives the beacons a way of drilling into TREs and allows them to do discovery queries on TREs without the TRE having to install an actual beacon within their network, which would potentially break their governance model. So just a little bit of potential impact on that. So at the moment, we're working with Treehus, FedNet, and Sale on deploying Hutch. But actually, it's a lot bigger when you start thinking about the DARE partnership and what it covers. So HDR UK, ADR, and some of the stretch TREs that are out there, including countries like Australia and Canada. And when we start thinking about what's happening in life sciences at the moment with Elixir and EOSC, this potentially could be a lot bigger. So to summarize, CoConnect has laid the foundation for quite a lot of stuff that we've been doing. And it's also then led to a lot of funding. So we've been reusing those technologies across a number of projects. So Demystify and Alleviate are both large UK program grants. Demystify is focused on multi-morbidity fibrosis. Alleviate is focused on pain. And we're using the same technologies that we used in CoConnect almost exactly in those projects to onboard more partners onto the HDR UK CaRROT Discovery Tool. We are also working with BBMRI ERIC, who are using the same technology, the BC RQuest, BC Link solution, to do biobanking in Europe. We're then also involved in BioCOVID, which is a large European Horizon project, which is looking at the federated COVID data across Europe. And finally, the new developments that we're doing with Elixir are all funded under DARE UK as part of one of the DARE UK exemplar sprints. The project's called Terrifics. So we're continuing to develop CaRROT off the back of CoConnect, and we have a small amount of funding to continue pushing that forward. And we're also developing Hutch to help the secure data environment users and data partners make data discoverable in a more remote fashion. A couple of mentions just to finish. So Jonathan Coldridge and Phil Crimpen are really responsible for Hutch, which I can't spell. Sam Cox and Callum MacDonald did most of the development for CaRROT, and Stian, Solon Reyes, and Carol Glug are largely responsible for the development of our crates. Thank you very much.